Good morning, ma'am.
Good morning, ma'am.
Good morning, everyone.
Good morning.
Good morning, ma'am.
Good morning, everyone. Afroz?
Good morning, ma'am.
Yeah, Afroz. So, what did you write in the chat section yesterday?
क्या मैम?
You don't know?
मैम
Did
वही कि
anyone else write for in place of you?
नो मैम.
Mind your
मैम
language when you are writing. Okay. So don't write anything else which is not needed. Dean sir read these messages sometimes. So you want to get a call from him, then it's fine. Otherwise, don't write anything which is not needed.
ओके मैम.
And Shreyas, are you online? He has not joined yet.
Excuse me, ma'am.
Yes.
मैम कल वीडियो में वो हिंदी में सपिष्ट और निकृष्ट मतलब उसका अलग रिलेटिव और अनरिलेटिव होता है ना?
हाँ हाँ आज यस रिलेटिव एंड एब्सोल्यूट आज डिस्कस करेंगे
Okay,
वही
ma'am.
वीडियो. I think we should start the class.
Okay.
Yes, ma'am.
Okay, so we were watching a video yesterday. First, I'll discuss what we have watched. Afroz, you will tell me what did you find interesting the most in the video?
मैम वो जो चला था कोहेरेंट सोर्स वाली वो.
Coherent sources wali. Okay, I thought you find the relativity one interesting.
वैसे समझ नहीं आ रहा था,
Relativity
बस
वाली
वही लिखा था, कोहेरेंट सोर्स।
रिलेटिविटी वाली ज्यादा अच्छी।
Okay, so we will start the discussion. Your first unit is relativity. I won't go into the calculational part, the derivation and all. We will just discuss the concepts. So your first unit is relativistic mechanics. What is relativity? Who will tell me? Relativity of motion. Suppose you're sitting on a chair in your at your home. So are you moving or are you at rest?
Address.
No, it's depend on the observer position.
Yeah, you may
Observer
find yourself
position.
that, yes, you may think that you are at rest, but relative to what? Relative to a person who is in the room. But actually, your room is on Earth, which is moving relative to Sun. Then again, Sun is moving relative to the center of galaxies and so on. So motion is not absolute. You always have to define the motion with respect to something, and that something is called reference. Motion is relative. The state of rest or motion is relative. Relative to what? To the observer. Suppose you are on a platform, in a railway station, you are on a platform, on the ground, you are standing over here. And a person is sitting in the train which is moving relative to the platform. So you will find that the person is moving with respect to you. But another person, let's call this person A, another person B, which is sitting inside this train, will find the person A at rest, right? In a train, this is moving relative to the ground. Two persons are sitting in the train. Yes? Is there any problem? Am I audible to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
So two persons A and B are sitting in the train, which is moving at a speed, let's say 50 kilometer per hour with respect to the ground. So you are on platform. Okay. So you will find the person A is moving with this much speed, 50 kilometer per hour. But person B will see, if he sees towards person A, he will feel that person A is not moving at all. It is at rest with respect to. Clear? That is why we say motion is relative. It is always with respect to the observer. That it depends upon the observer. Where is the observer? So if the observer is B, that means person A is at rest. But if the observer is on the ground, then your voice is not clear. Who was speaking? Should I continue? Who had question? Who was asking?
Continue.
So it depends upon the observer. If observer is inside the train, that means the person B. For the person inside the train, person A will be at rest. However, for the person on the ground, this person A is moving at this much speed, 50 kilometer per hour. That is why we say motion is relative. So now you want to calculate the or write the speed of person A, right? Speed of person A. What will be the speed of A? Who will tell me?
Ma'am, किसके respect में पूछते हैं?
Sorry.
मैम speed में कौन observe करे इसकी respect में
Yes,
निकाल ली
yes.
ये
So we
ना
can't, yes. So we can't determine the speed of A absolutely. We can't fix the speed of A. We can only determine the speed of A relative to something, relative to some reference frame. So speed is not absolute. It is relative. Relative and not absolute. Okay, now tell me one thing. There are some basic laws or fundamental laws of physics, right? Like F is equal to ma, like these, some fundamental laws of physics. Will these laws depend whether the person is at rest or in motion, whether the observer is at rest or motion?
When observer is at rest. And these laws are
Will
valid
these
in only
laws,
in inertial and only inertial frame are valid.
these laws of physics will be same
Yes, ma'am.
for a person at rest or in motion, whereas
No,
motion
ma'am.
should be uniform.
No, ma'am.
It should be a uniform motion or an accelerated motion.
Yes, ma'am.
Then for the case of rest or uniform motion in a straight line or non-accelerated systems, the laws of physics will be same. This is called classical theory of relativity. That laws of physics, basic laws of physics will be same for the persons at rest or in uniform motion. This is called classical theory of relativity. In classical theory of relativity, the speed is different depending upon the observer. However, some quantities like length or space, time, mass, these are not relative, these are absolute. In case of classical theory of relativity, basically classical theory of relativity was mainly given by Newton, and we encounter classical theory of relativity in our daily life. So you don't see any changes in length, time, mass. You find all these quantities to be absolute. But in 19th century, Maxwell, one of the scientists, and you know him by his famous Maxwell's four equations. He proposed that speed of light is c is constant quantity, is a constant quantity, and its value is equal to, what is the value of speed of light?
3 into 10 to power 8.
So yes, we
8
denote
meter
this
per
by c, and this is equal to 3 into 10 to power 8 meter per second. So Maxwell said that speed of light is constant. It is 3 into 10 to power 8 meter per second. Also, Maxwell analyzed the EM waves. He determined their speed, and he found that EM waves also carried the speed of. We now know that light is also an example of EM wave. That time he did not know. So he determined the speed of light is c, and he also analyzed EM waves and determined their velocity or speed, and he found that EM waves also carries a velocity or speed of c. So he said that its velocity is same or speed is same. But at that time, what was thought? I'll erase this. At that time, what was thought that similar to sound waves require some medium, right? Can you listen to someone if there is no air in the surroundings?
No, ma'am.
So that is why in space, you know, na, in space where there is vacuum and no air, there is no medium to carry the sound waves. Hence, you can't listen to anyone in space. So the astronauts, if they are in some space shuttle, they can listen to each other, provided there some must be some medium to carry those sound waves. So at that time of Maxwell, it was thought that just like sound waves, EM waves also require some medium, for propagation. For propagation, just like sound waves. You tell me, does EM waves require a medium?
No, ma'am.
Okay, tell me, does EM wave require some medium for propagation?
No, ma'am.
No, ma'am.
How do you know? How do you know?
Ma'am, light comes to the earth in vacuum.
Yes, ma'am.
Yes, yes. Sunlight comes to Earth, yes, without the presence of any medium in the space. Yes. So now we know this that EM waves does not require some medium. But at that time, it was thought that as sunlight is reaching towards Earth, so maybe universe also has some medium which carries these EM waves. Like if this is the sun, right? And on Earth, we are getting sunlight. At the time of Maxwell, it was thought that this space is filled with some medium which we cannot see. That is, that medium is invisible or transparent. That is why light can pass through that medium. Transparent, massless, it does not has mass. That is why we can't determine this. And with some other properties, that the space is filled with, uniformly filled with some invisible, transparent and massless medium, and that medium was proposed to be called ether. So for quite a long time, it was thought that there is ether which is filled uniformly throughout the universe, which is responsible for the propagation of these EM waves. So various scientists conducted a number of experiments to prove the existence of ether. And one such experiment, which was highly famous, is Michelson-Morley experiment. You will study this experiment, all the experimental arrangement, what was its outcome, and what was the conclusion for this in your first semester, Michelson-Morley experiment. What was the most interesting part of this experiment is that when you conduct an experiment, the experiment is successful only if you find the outcome which is in line with your thought. But in this case, it was a negative experiment. That means they wanted to prove the existence of ether, was called negative experiment. They wanted to prove the existence of ether, but their experiment conclusively stated the fact that there is no such medium as ether. All the speculations about the ether medium were removed after this experiment was conducted. So it is a negative experiment because the ether they were trying to find out. They wanted to find the existence of ether, but when the outcome of experiment was found out, they found that there is no such thing as ether. So you will study in your first semester the experimental arrangement, how does the process of this experiment took place, and then the negative results and how those negative results were explained. I will not go into details of this experiment. You can write some of the topics, so it will help you, like small things like ether, Michelson-Morley experiment. So you will like remember this story. Otherwise, this you will forget soon.
Okay, ma'am.
So Michelson-Morley experiment proved that there is no ether. There is no ether. What does it indicate? That EM waves does not require any medium to propagate. And what is the speed or velocity of EM waves?
Three into 10 to the power 8 meter.
It's C, denoted by C, propagate, and has velocity or speed equal to C. Is it same in all directions?
Yes, ma'am.
Like if some object is moving like this, it will have velocity in this direction. If you find, or suppose it is moving in some other direction, let's say diagonally, its velocity is V. When you find the velocity in X direction, it will be different. And you find the velocity in, let's say, Y direction, you will find the velocity to be different. But in case of light, this is the speciality about the speed of light. It is same in all directions. But okay, tell me what is the velocity of light in some medium?
Ma'am, it will decrease.
What is the velocity of light in any medium?
Depending on its refractive index.
And the length and the wavelength.
Sorry?
Ma'am, it depends on refractive index.
Yeah, what is the expression? What is the formula? It
C
is
equals
C over
C
by
C over
C
N,
by N.
and where N is the refractive index of the medium.
Yes,
So
ma'am.
why does they say that the speed of light is constant if it depends upon medium?
Ma'am, refractive index, sorry, V
Refractive
equals
index
to
of
C
air is
upon
1.
And yeah, I'm asking you this, like it's the general expression, right? That speed of light is constant. So but it depends upon the medium. So whenever you say that speed of light is constant, you write the value of speed of light C. You write that speed of light in vacuum is constant. You got it? Don't confuse the two.
Yes.
In your
Yes, ma'am.
relativistic mechanics, you will often encounter the term that speed of light is constant. Einstein proposed a special theory of relativity. Its first postulate was speed of light is constant. But that means it is in vacuum. Whereas it depends upon the medium. If you're taking some medium and propagating the light in that medium, it will vary. So the postulate in relativistic mechanics is complete postulate is that speed of light in vacuum is constant in all directions. Okay, so at the time of Einstein, he took this idea forward that speed of light is constant. In general, object speed V, like in our earlier discussion, for the case of train, if a train is moving with velocity V is equal to, let's say, 50 kilometer per hour, and there were two persons sitting inside the train, person A and person B. One observer is person B and another observer is sitting on the ground. But they are observing speed of B, object A. So we discussed about it that it will depend upon whether the observer is B or is it on the ground. Whereas in case of light, the speed of light is same. It does not depend upon the observer. A person sitting inside the train or the person on the ground, they both will observe the speed of light. Suppose person A starts a torch on the torch and there is a pulse of light. Person B also observe the speed of light to be c, and person on the ground will also see the light or speed of light to be c. It will not see it as c plus v, or if the train is moving in opposite direction, it is c minus v, not like that. It will also observe the speed of light to be c. This was Einstein's special theory of relativity's first postulate. So don't confuse it with medium. In different mediums, velocity changes c by n, but we are taking the case of vacuum only. So we are saying that speed does not depend upon the observer. Speed of light does not depend upon the observer. It will be c always. Whether the person is inside the train
Ma'am,
or the person, yes,
can air resistance affect the speed of light?
resistance to what? Which resistance? Air
Air
resistance.
resistance. Yes, ma'am.
Air resistance.
Yes, ma'am. Air resistance.
See, air is also a case of medium, right?
Yes, ma'am.
So its speed will be different. But resistance does not affect. The refractive index of the medium will affect.
Yes, ma'am.
Why it is that? Because see, the resistance will only take part if the wave is propagating with the help of some medium, like in the case of sound waves. How it travels? Sound waves, it pushes the particles of the medium and then it pushes the another particle of the medium, like that sound wave travels. You know the process, right? How sound waves travel. It
Yes.
the particles of the medium, it is traveled through that. So their resistance will be counted. But in case of EM waves, they don't require any medium. They will propagate through the medium. Only the value of speed will depend upon the refractive index of the medium. Why? Because it changes the wavelength of the medium. Oh, sorry, wavelength of
Yes,
the
ma'am.
wave. Sorry. That's how it is propagated, and that's how velocity gets affected, because its wavelength is changed and its velocity then it's changed because frequency remains same. Frequency is same, but wavelength is changing. That is why velocity is also changed. So here resistance does not play any role here. Clear?
Yes, ma'am.
So yeah, I was saying if
Ma'am.
there is some another object, yeah.
No, I'm clear.
Okay. So if there is some object with the velocity v, which is very, very less than the speed of light c, then its speed will depend upon the observer. However, in the case of pulse of light, which is traveling with the speed of light c, it will not depend upon the observer. It will always be c. So this is the first postulate of special theory of relativity given by Einstein. इसको short form में कैसे लिखते हैं? STR. Second postulate I want to discuss. Yes.
Ma'am, you have said that air resistance will have no effect or negligible effect on light propagation.
No effect. According to me, it should not have any effect.
The effect like
Resistance is what?
absorption,
Resistance
scattering,
is what? Yeah, it
refraction or
changes its
diffraction.
direction or it absorbs the light. Yeah, it does not change its speed. We are talking about speed only.
It does not affect its speed.
Yes.
If it's in
If it is
absorption
absorbed,
energy,
if it is.
ma'am, if this affects absorb some energy, it will have some negligible effect on light speed or not.
Can you repeat your question?
And the effect like absorption, scattering, reflection, and diffraction absorb some energy from light waves. So
Yes.
will it decrease some speed, like negligible effect on the speed
Its
of light
velocity will
propagation or
also
not?
always be. Its velocity will always be c if it is vacuum. If it is air you're considering, it will always be the velocity in the medium, that medium. It will always, if it is absorbed, see there is no pulse at all. Right? It won't move at all. If there is scattering, there is change in direction. When you will study the quantum physics, you will see that it is what are EM waves. Basically, what is light? It is the basically it is in the form of photons. So basically, a particle will come. If it is scattered by some medium, it will change its direction. Earlier also, it was its speed velocity was c. After the scattering, then also its speed will be c. If it is some medium,
So
then there will be c by n.
and can we conclude that not only reflective index but some other effects also take place and speed is affected by those effects?
No, I'm saying that speed is not affected. See, if you consider this in the form of photon, photon will always have energy E is equal to h nu or hc by lambda. It will always have this energy. You can't change this energy expression by h. This is Planck's constant. This is a universal constant. Its value 6.6 into 10 raised to power minus 34 joules second. It will always stay the same. Okay. This frequency, once it's in a medium and nothing changes its frequency, it will be same. So here in terms of this expression, in terms of wavelength, again this constant is c. So photon will always travel with the speed of light. If there is scattering, there is change in the direction of the medium. If there is, suppose its energy decreases. In case of photon, its energy decreases. Why? Because some of the energy is absorbed or something like that. Where this effect will be reflected in terms of its wavelength. We will say that its wavelength increases. If energy of photon decreases, we say its wavelength increases, or we say its frequency is decreased. And you will
Okay,
see,
thank you.
you will think that how frequency is decreased if energy is decreased. We said earlier that frequency is constant. That thing we said for a change in medium. Here we are taking the same medium and taking the case of only scattering. A photon comes, there is some material medium for the scattering, so there must be some atom or electron or any particle. So if photon comes, it will be scattered by this particle and it will change its direction. If it is elastic scattering, its energy will be same. So earlier if it was E, then again it will be E is equal to h nu or hc by lambda. And if it is elastic scattering, it will remain same, h nu or hc by lambda. However, if this atom, they absorb some of the energy of photon, okay, in that case its energy will be decreased. It will be E prime, and now it will not be equal to h nu, it will be equal to h nu prime, or it will be equal to hc divided by lambda prime. So what will be the effect of scattering? Its frequency will decrease or its wavelength will increase. However, the speed in case of photon always travels with the speed of light. That is c in vacuum, if we consider. Any doubt you can ask it now.
मैम एक
You
कंक्लूजन
know
पॉइंट
there is
क्या
बोलो क्या बोल रहे हो?
मैम आपने जब फोटोन कहा ना, तो फोटोन का स्पीड तो चेंज होगा नहीं, तो वो जब
हाँ,
मीडियम तो वो जब मीडियम से टकराएगा तो वो उसी स्पीड से या तो वापस चला जाएगा या फिर सीधे आएगा या फिर उसका डायरेक्शन
अगर
चेंज हो
if it goes in that medium, then its velocity will be different. See, that is why we take particle nature into account when it interacts with some medium, with some material particle. If it goes through the medium, then we for propagation purpose we take EM waves. You remember?
Yes.
Then we can say that its speed will be different.
मैम वो वाला केस आ जाता है जहाँ पे लाइट आता है, कुछ लाइट रिफ्लेक्ट हो जाता है, कुछ लाइट कुछ एब्जॉर्ब हो जाता है।
हाँ, see,
वैसा
जो
ही
पार्ट
कुछ
रिफ्लेक्ट होगा, it will travel with velocity of light. See, if we consider vacuum, जो medium में जाएगा, it will be c by n.
यस मैम,
And its wavelength will be lambda. In its wavelength will be lambda prime.
यस मैम,
Okay.
यस मैम।
So what is the first postulate of STR? You write it down. Although we will study in detail when you will arrive at college. You write special theory of relativity, bracket में लिखो STR. First postulate, write down that first postulate only. Speed of light in vacuum.
Yes, ma'am.
It has two postulates. Second postulate, we will discuss in detail when I'll start the unit. Like we need frame of references and all, and we'll discuss it afterwards. So first postulate is speed of light is generally some people don't write speed of light in vacuum, but it means this like it's hidden in the postulate itself. Speed of light is same. For in all inertial frames of reference. I'll tell you what inertial frame is. What is frame of reference? You got any idea from the whole discussion? What is a frame of reference?
From which perspective we are watching the event.
Yes, yes. The frame of reference is something relative to which we are observing the motion. So basically, frame of references are of two types. It's inertial and non-inertial. We'll discuss in brief only, inertial and non-inertial. Inertial frames of references are those which are either at rest or are moving with the uniform velocity along a straight line. They are in uniform motion. Or you can say the unaccelerated one. Whereas non-inertial are accelerated frames of reference. We write this down. Done?
Yes, ma'am.
Okay, so I told you earlier that if you are at rest or you are moving uniformly along a straight line without any acceleration, you will find the speed of light to be c. So basically, in inertial frames of reference, speed of light is always c. This is STR's first postulate. It means STR only deals with inertial frames of reference. I have not talked about any accelerated frame. I have not told you that if the object is, if the observer is moving with acceleration, will it find the speed of light to be c or not? It only deals with inertial frames. Your first semester course, the first unit, relativistic mechanics, we will only study for the inertial frames. Non-inertial frames are not a part of your syllabus. Actually, these accelerated frame of references, these are accounted for in another theory by Einstein, which is general theory of relativity, GTR, and GTR is not a part of your syllabus. In GTR, Einstein deals with the accelerated frames. Should we move ahead?
Yes, ma'am.
Yes.
Okay. Okay, so you tell me that is length, r length and time absolute or relative?
Absolute.
Absolute.
Okay, anyone else?
In classical theory, absolute.
Relative.
Relative. How can you say that it is relative?
Because
Ma'am, when we travel to the greater
One by
than
one,
speed
one
of
by
light,
one.
then it
Okay, issue, you tell me first. Issue,
Yes,
are
ma'am.
you there? Yeah, so you tell
Yes,
me
ma'am.
length and time, are they absolute or relative?
Ma'am, length, I guess it's absolute, but time is relative.
Okay, you see, you think that length is absolute and time is relative. How do you say that? Like, first tell me why do you think that length is absolute?
Ma'am, because it will not change from any perspective if you are watching the lens. It will not change its dimension.
Okay, fine. And how do you think that time is relative?
Um, Sometime right now I'm not having the accurate example for this.
Okay, and
Ma'am, may
okay,
I?
anyone else?
Ma'am, may I?
Yes. Yes.
Ma'am, according to me,
With a rod in a train and the train is traveling comparable to the speed of light, then the rod when the observer is sitting on the train, then the rod will appear to be of 1 meter if it is of 1 meter, but a observer which is standing outside the train, because the train is moving with the speed comparable to the speed of light, the length of the rod will appear to be shorter.
Okay, where did you study this? Where did you see this?
Yesterday,
Because we don't travel with the
it-
speed of light. Yesterday, yes, in
I'm
yes, yesterday we did. Yes, yes, yes.
and, and ma'am,
But have
when
you?
when a watch,
Yeah, speak.
ma'am, should I
What were
do?
you saying? Yes, yes.
And when same goes with the watch, an experiment also was conducted in the satellite. A watch was placed, and after that the watch was observed. When the satellite was, matlab, after that the watch was observed, and the time appeared to be moving slow.
Yes, you are correct.
In the,
So how we will put these things? How this thoughts for length and time relativity comes into picture? I'll start from that only. So Einstein noticed this thing. The speed of light, why it does not depend upon the state of rest or motion, whereas speed of any other object v, it depends upon the state of rest or motion of the observer. So why does light does not depend upon that state? So what does he do? He thinks that c is equal to as velocity or speed is equal to distance over time. So he thought that if c is always constant, so it may be possible that this distance, which can be thought of as space or length, and this time, they are changing separately such that their ratio is always constant. We thought of this speed constancy in the speed of light like this. He thought that maybe length and time are changing separately such that always the ratio is same. So what is this distance? Suppose this distance is d and time is t. So this is the distance light travels in time d. So he thinks it like that. If c is always constant, maybe in motion, what happens is distance is decreased and time is increased such that their ratio will be constant. It is clear now. If numerator is decreasing and along with that denominator is increasing, the ratio will remain same. So he proposed an idea. He said that in the case of motion, and then motion is also having one condition. It should be with velocity v comparable to the speed of light c. For such large moving objects, you will find that the distance d is decreasing. It means he said that there is contraction in length. Contraction means decrease in length. So he said there is contraction in length and increasing time or time interval in time interval for an observer moving with velocity v comparable to the speed of light. He said that because in our daily lives, we don't move with the speed of light move with the speed comparable to c. Because the fastest velocity achievable is still far less than the speed of light. So he said that as we don't encounter these speeds, we don't encounter these two phenomena in our daily lives. However, for the observer moving with speed comparable to the speed of light, there will be length contraction. We'll study these two phenomena in detail, that length contraction happens, but in which dimension? And the increasing time interval is called time dilation. Dilation means increase. We'll discuss this in detail when we start our unit. So these two phenomena are a result of special theory of relativity. And they are only seen when the observer is moving with velocity v comparable to the velocity of light. So Actually, what length contraction means is, suppose the observer is moving, and there should be clarity in your mind about one thing. Suppose there is a road, let's say AB. If it is at rest, suppose this is lying at rest on a bench, and you are moving relative to this road with a velocity v comparable to velocity of light, you will find that its length will be less than its actual length, which is AB. This L is the length which you are observing if you are moving with velocity comparable to c with respect to this rod. In second case, now you are at rest, but this rod is moving. Its actual length is AB and it is moving with v comparable to c. Again, in this case, you will find its length to be L. So it does not depend whether the road is at rest or road is moving. There should be relative motion between the object and the observer. I hope I am clear. I'll repeat this thing again. It's not the moving road which will appear shorter only. If you are at rest and the road is moving, it means there is a relative motion between the road and the observer. In the second case, the road is at rest, however, you are moving with v comparable to c. Again, there is a relative motion between the object and the observer. In both of the cases, the observer will observe the length of road to be L, which is less than AB. So what is the condition for length contraction? There should be relative motion between the object and the observer. And motion should be such that the velocity should be comparable to c. Clear?
Ma'am,
Yes, ma'am.
could you tell me how this will happen?
Sorry?
Ma'am, could you tell me how it was happened? Means how length will be shorter than its actual length?
You will measure it to be like that. Suppose, see, you can't visualize this practically because we can't see it happening in front of us. We are not moving it at the speed of light c. That is why we can't see this happening in front of us. There is no practical example for length contraction. Only if we are moving like for space shuttles or something, you can see the length. When you measure the length, especially in case of time clocks, it has happened. Like in the video yesterday. So what the experiment was about? So they placed clocks in a space shuttle. They placed some clocks and they sent this satellite in the outer space, and this satellite was made to orbit around the Earth for a few years or something. When it returned back on the Earth, their time was noted down, and it was compared with the clocks placed over the Earth, and they found that time was actually dilated. So time dilation, there are practical examples, other examples also, but for length contraction, like you can't simultaneously measure the length of the object when you are moving with respect to the object. Why is it so? Suppose you are moving with respect to observer. Let's take this case. You are moving with respect to the object. You place a meter rod over this point A here, right? You have to place the meter rod simultaneously to points A and B such that you can measure the length of the road. But by the time you will do so, you will move ahead of the road, or road will move past you. Similarly, in the case of motion of road, this will happen. The condition of measurement of length is you placed the end of meter rod simultaneously over these points. So this was the idea which was proposed by Einstein. I'll give you practical example of length contraction. tomorrow if there is any experiment regarding the length contraction. Right now, you cannot visualize this. Similarly, in case of time dilation, there is example that they placed clocks in the space shuttle. They sent into the outer space. It was made to orbit around the Earth for several years, for a few years, and then when it came back to Earth, the time period which was reported on the clocks, it was different from the clocks which were placed on the Earth. You watched Interstellar movie also, right?
Yes, ma'am.
Interstellar movie who has watched? You remember when they went to another planet and came back, her daughter was older
Older
than
than
himself.
him.
Yeah, she was older than himself. Why is
वो
that
तो
so?
ब्लैक होल के पास गए थे हुआ था।
There are actually two effects that played their part. First effect is time dilation, because when they were moving in the space shuttle, their speed was quite comparable to that of light, so the time was dilated. And the second is the effect of gravity. And second effect plays major part. They went the planet which they went to. Remember, they said that their gravity is so strong that 7 years on the Earth is equivalent to
Yes, ma'am.
1 hour on the planet or something like that.
It was near a
In
black
that
hole.
case,
Yes, ma'am.
yeah, in that case, it's the gravity which is causing that phenomena to happen. But yeah, there is some part of time dilation, some contribution from this also. So gravity, it is accommodated in GTR, which is not a part of your syllabus. We'll only deal with the time dilation, then length contraction, then also the mass. Mass is relative or absolute?
Absolute.
मैम relative.
क्या है mass? बताओ.
Absolute.
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 Okay. But absolute only in classical theory of relativity. In special theory of relativity, like length and time, mass also changes with the speed. If velocity increases, speed increases, mass also increases. It's also not absolute, it is also relative. So length, time, mass, these are relative quantities in special theory of relativity. So there is a formula. I'll write it here. This is the formula which tells us this is c, which is constant. This is v, which is the velocity of the object whose mass we are determining. What is m naught? Can you guess?
Mass at rest.
Mass of object.
It is
Initial
object at rest. Then its velocity is zero.
Yes, ma'am.
Right. So this is called
Yes,
rest
ma'am.
mass. And what we then, if this is the rest mass, what we will call m? We call m to be the relativistic mass. Relativistic mass.
Relative mass.
Relativistic mass. The unit is relativistic mechanics and not relative mechanics. So yeah, we'll continue the discussion in a tomorrow lecture. I'll stop sharing now.
Non-attendance.
Yeah, I'm taking. So by the end of the lecture, the attendance suddenly increases.
Yes, ma'am.
Yes.
Is there any coincidence or a reason behind it?
कुछ बच्चे सिर्फ अटेंडेंस लगाने
कुछ बच्चे अटेंडेंस लेने के लिए आ जाते हैं.
Yes. So you all can be traced down, right? So try to come on
Ma'am,
time in the lecture.
मैम ऐसा किया कीजिए कि 20 में अटेंडेंस कर लीजिए साढ़े
क्या?
12 बजे मैम 20 में अटेंडेंस ले लेंगे तो फिर एक क्लास
Okay. Anyways, you can all be traced down. Okay. I'll end the meeting
Okay, ma'am.
now. Thank you,
Okay,
everyone.
ma'am.
Yes.
Thank you, ma'am.
Thank you. Thank you, ma'am.
मैम टाइम डायलेशन का
Thank you,
कोई
ma'am.
फॉर्मूला होता है क्या?
Thank you, ma'am.
Bolo, bolo. Okay, I'll ask the question tomorrow. Okay. Note it down.
Oh.
So you don't forget. Okay.
ओके मैम.
Thank you, ma'am.